Hello and welcome again today. So, today I'm going to cover one or two, maybe the questions, two questions of lead code, wherein this first question is asked in my coding round of Microsoft. Okay, this is the first question when coding round came, and this is the on-campus placement when college came to our campus. This is the first round. This is the first question which I have got from the Microsoft. Okay, and this is related to sub-array sum. This is Microsoft asked question. I repeat. Okay, let's see the question. You are given an array of size n, and the task is to count the number of subarrays having an average exactly equal to k. So you have to count the number of subarrays such that the average of that subarray is k. Average of that subarray is k. Okay, so let's just quickly go. What does it mean to say that average from some sub subarray should be k? Okay. Now we know that what is the sum from L to R? We know it's prefix sum until R minus prefix sum until L minus 1. Okay. So average could be this thing divided by size of our subarray will be R minus L plus 1. This could be the size of our subarray. If subarray is from this first index to third index, the size will be 3 minus 1 plus 1, which is 3. So size of subarray is 3. So R minus L plus 1. Now this is equal to k. That's what they have told. So let me take this on the side. Just quickly have this derivation to make it similar to what we have learned today. We have to make it similar to what template we have learned. That sum of some subarray, so me sum subarray should be k. Okay, and there we need to find either the count of such subarrays, minimum or maximum length. So then this should be equal to prefix sum until r minus prefix sum till L minus 1. Okay. If I made it a more specific than k into r minus L minus 1 into k, this should be equal to prefix sum of r minus prefix sum till L minus 1. Okay. So basically, if I say it will be prefix sum of r minus r into k is equal to prefix sum until L minus 1 minus L minus 1 into k. Oh, what does this mean? Does this mean if I decrease every element, so let's say if I have to do sum until r, then I need to decrease the element by r times, k times, so r by r into k times. So does that mean I need to decrease every element from 0 to r by k by k by k by k? And the same thing from L minus 1, I have to decrease every element by L minus 1 into k. Okay. Simply, let's just let's decrease each element from 0 to n by k. Okay, and if I decrease each element by k, then this sum would be equal to this sum. Oh, does that mean that sum should be 0? The average sum or the sum of elements from L to R should be 0. It should be 0. So our condition has become now, after decreasing each element by k, if we take the sum of such subarrays, the sum of such subarrays should be k, or the average of such subarrays should be k. It should be k. Okay. So if I decrease this each element of array by k and each element of array by k, then this means that array of r should be equal to array of L minus 1. Okay. So then our average should be equal to k. Average should be equal to 0. And if average is 0, then sum should also be 0 because average is nothing but sum divided by length. Okay. So our question has rephrased. So we can say this as the rephrased question has become that we have to count number of subarrays. Okay, they have asked for total number of subarrays. So we have to count number of subarrays having sum equal to 0. Clear? So this we have rephrased now. Okay, let's just see with the example also. Let me just quickly have an array, this array, 1, 4, 2, 6, and 10. Okay, let's quickly have this 1, 4, 2, 6, and 10. Okay, so let's just take any one of this array whose average is k, just to make you understand. The average should be k. So let's say 4 plus 2, 6 plus 6, 12. 12 divided by 3 is 4. So this average is k. The average of this subarray is coming as k. Okay, is coming as 4. The average of this 3, 4 plus 2 plus 6 divided by 3 is coming as 4. What if I decrease this by k times? So this array would become 1 minus 4 will be minus 3. 4 minus 4 will be 0. 2 minus 4 will be minus 2. 6 minus 2 will be 2. 6 minus 4 will be 2. And 10 minus 4 will be 6. So this is what my array becomes. Okay. So now the sum of this array, the sum of this subarray, 0 plus minus 2 plus 2 is what? 0. So the average of this subarray is k, and if I decrease the subarray by k times this, after this derivation, I know this. Okay, so you need a little bit of derivation to set it into your template, which we have learned yesterday. Now, what do I just need to check? I just need to check that sum of this subarray should be 0. Okay, now it has decreased to this thing. Now, simply we have learned yesterday. So without wasting time, let's just go to the question. Okay, so let's just go to the code. How will it work? Let's just simply see the code. Okay, you have asked this above question. What can we do? We'll have one sum is equal to 0 and one answer also equals to 0. We'll go. Okay, you will be given n and k also. Okay, so we will define one map also to store our sum and frequency. Yes, this is count related question. Clear? What we can do is, while doing sum, we will add array I minus k, because we have to decrease each element by k. And now we have to just check the sum 0. So first, for 0 to I subarray, we will check if sum is equal to 0, we will do answer plus plus. And second, for L to R subarray, what we need to check, if we have found this sum minus 0 already in map, okay, we will add whatever its frequency, and every time we will do map of sum plus plus. See how easy it has become. This is actually asked in my Microsoft coding round test, and see how easy it's after learning this subarray sum using prefixes. Okay, let's just quickly go to the next question and see. Okay, so there's another question. Here you are given hours, a list of the number of hours worked per day for a given employee. Okay, and a day is considered to be a tiring day if and only if the number of hours worked is strictly greater than 8. If the number of hours you have worked is greater than 8, then it's the tiring day. Now, a well performing interval is an interval of days for which the number of tiring days is strictly larger than the number of non tiring days. Now, what it mean by interval is simply subarray. So, a subarray of days is said to be a well performing subarray or interval if the number of tiring days is strictly more than the number of non tiring days. And you have to return the length of such longest well performing interval, means maximum length of subarray satisfying this condition. Which condition? Where number of tiring days is greater than number of non tiring days. Now, what does number of tiring days means? Tiring day means you have worked some amount of numbers which is greater than 8. Okay, so this two are tiring days. 6 is not a tiring day, 0 is not, again 6 is not, this 6 is not, and this 9 is yes. Okay, so we have to play between a tiring day and a non-tiring day. We have seen such a kind of question yesterday, wherein we have to play between 0 and 1. I have told you the logic also there. Okay, between 0 and 1 you have to play. So we made that zeros to be minus ones and ones to be plus ones only, and then we have done that summation to be 0, where we have to find equal number of zeros and ones in the subarrays. Here what we can do, some amount greater than 8 we can make it plus 1, and some amount less than 8, less than or equal to 8, we can make it minus 1. So now the summation of that should be greater than 0. Okay, okay, we can, what we can do is we can make uh, hours greater than 8 to be 1, and hours less than equal to 8 to be minus 1. So now our sum of subarray, what, should be greater than 0. Now for 0 to I condition, it's okay. We can check while doing the sum that if sum is greater than 0, we will take that maxi length of subarray. Okay. But what for L to R subarray, where we have to do something sum minus k? We will check in the map if map dot find sum minus k. That's what we are doing right here. What we will check in this condition, map dot find sum minus k. What should be our k? Okay. So minimum of minimum, what can happen? Minimum of minimum, our sum could be what? Our sum should be at least once. This means it should be greater than 0, means our sum should be at least 1. Okay. So if we will find that at least condition, we will always be checking for 0 for L to R subarray. Okay. We'll check for 1. Surely we can check for 2. We can check for 3. We can check for n. So we just need to check for 1 and every other conditions will be satisfied. Okay. So we just need to check if map dot find sum minus 1 is not equal to map dot n, then we will take the maxi length here. Okay. Let's just go and see the example to clarify, to be clarify. Okay. I will taking some other example, not this, because this has 0 to I subarray only the answer lies in. Let me take another example. Let me just take another example. Okay. 59992699718. Now, it's not necessary, it's not given, it's not at all given that you have to find in such a way that number of tiring days are as maximums as possible. Okay, the catch is it's not mentioned anywhere that you have to find such a subarray where number of tiring days is as big as possible. That means, what does that means? That means it's not necessary, it's not at all necessary that you will find this subarray, okay, from first index to 1 2 3 4 5 6 sixth index. Okay, this is one, this is one where tiring days are 4 and non-tiring days are 2. Okay, in 1 to 6 tiring days are 4 and non-tiring days are 2. There are 4 nines, 1 2 and 1 6. Okay, now there could be another array possible. uh, let's say this 5 until 6. So here tiring days are what? 4. But non-tiring days are what? 3. Non-tiring days are what? 3. Okay. Now there could be this array also possible. Starting from starting from 1 index and going till 7 index. Here also tiring days will be 4 and non-tiring days will be 3 because we have 7. At 7th index we have this 7. So what I mean to say is your this condition where number of tiring days, the condition where the condition where number of tiring days is greater than non-tiring days by more than one, by more than one, it will be covered in 0 to I subarray always. It will be covered in 0 to I sub-array always. Otherwise, otherwise, if tiring and non-tiring day have difference of 1, it will be covered in L2R sub-array. It will be covered in L2R sub-array. If it is in between somewhere, if it is in between somewhere. So in between somewhere only, okay, it can never be possible that tiring days is more than non-tiring days. Okay, it means, let's say you have this sub-array. Let me just quickly draw this sub-array. Let's say you have this sub-array 2, 9, 9, 4, 5, 9, 9. Okay, and you have taken this thing. Let's say this you have taken where you have 3 tiring days and 2 non-tiring days. Okay, so it will be 1. Your difference will be 1. Now, let's say someone can say that I can take this also, where my tiring days are 4 and my non-tiring days are 2. Will that be possible? No. Why? Because we have then this non-tiring day and we have to find maximum length. We do not have to maximize the number of tiring days. We have to maximize the length of subarray such that the tiring days is just greater than non-tiring days. The condition should be tiring should be greater than non-tiring. It doesn't mean that tiring should be as big as possible. Okay, so then why not to take this 2 also? We can take full array then, 2 to 9. Okay, that means 0 to 0, 1, 2, 3, 4, 5, 6, 0 to 6 index. Okay, so as I have said, for it will always be tiring greater than non-tiring by 1, by 1 index or by 1 difference, by 1 difference. Okay, and if the difference could be more, if the tiring days are more than non-tiring days by 2, 3 something, then it could be 0 to I array only. For L to R array, it will be always tiring greater than non-tiring by 1 only. Okay, by 1 only. So let's just quickly move to the question and code it now. Clear? So you are given here n is equal to hours dot size, and we should have one map. These are the trickiest questions which could be solved with this, but the main concept lies under how you will make it to simple question where we have those templates to apply, which we have learned. Okay, sum is initially 0 and let the maximum length also initially to be 0. Okay, we need to find that longest performing interval. So we will store in map sum and indexes at this time. We'll go I0 till n. What I can do, if my hours of I is greater than 8, I'll do sum plus plus, else I'll do sum minus minus. So if my sum is greater than 0, okay, of course I have this maximum answer over here for 0 to ith index, which will be I plus 1 until. And I need to check if in my map sum minus 1, at least I can find this thing not equal to map dot end. Okay, at some point you have always find, if that array exists, at some point you will always find tiring to be greater than non-tiring. So it will cover all the scenarios. Okay, your answer will be again maximum of answer comma I minus this map of sum minus 1. Now this is maximum length we have to find, so we have to check if map dot find sum equal to map dot end. So if we have not put this sum until now, then only we will put, because we have to find maximum length. So map of sum is equal to I, we will put. What did I made? Maxi or answer? Let this be answer only then. Okay. I hope you got this very clearly, how to make this condition. Okay. This is actually a very good question. It can be asked to many good companies. Clear? Fine. Okay, so we have completed today's session. Do hit like, share, and subscribe if you have learned a lot of things. This is actually very, very important topic, which could be asked in many top MNC companies while coding rounds, while interview preparations, while they ask the real-time interviews. Everywhere, it's very useful. Stay tuned for the next video. Now, in the next video, I'll be covering little advanced topic of subarray sum using map, wherein we will be covering beat bit manipulations plus Saberism. Okay, stay tuned, stay safe. Bye bye.